Hey guys, we are going to finish up our notes packet now with the last section 0.3, and it's all about analyzing our data. And so I'm going to move my face around a couple of times here. So you should have your notes packet, last section. It's short, so here we go. All right, get me down here. When it comes to talking about this last little section, you have to understand our notes really have been taken in a progression. We've started with a hypothesis. We've started from that hypothesis to build an experiment. We've talked about ways to collect and graphically represent our data. We've talked about math that is necessary to run on our data to be able to interpret it well. And then we have to write something about it. We have to explain the results of our experiment. And so we do that in biology in what is called the CER format. So chances are you have actually heard of this before. I'm fingers crossed hoping that you have heard of it before. CE and R stand for claim, evidence, and reasoning. And we're going to go through what each of these really means. And then we will work out of an example and make sure that we understand how we would write a claim, evidence, reason, explanation. So this sometimes is called a scientific explanation. If you were to hear that, if you were to be asked to write a scientific explanation for an experiment on the AP test, if they give you an experiment and they say, explain this, that is your clue to use the CER format. All right, so the C stands for a claim. A claim is what you know about your data, pretty much, about your experiment. So it's the what. And really, what we are doing here is we are making a claim, a statement about the results of our experiments. Sometimes the claim goes directly back to analyzing the hypothesis or the guiding question that we started with. If we are asked to explain an experiment, your claim should do this. If we are asked to develop a scientific explanation for a model, not necessarily an experiment that has some data to it, we would use this second bullet, which is just using your claim to make a statement about trends that exist. But a claim is, what do you know? What do you know based on the results of the experiment? That would be our claim. And so I always find it easiest to work out of an example. And so let's take a second, because this will be important for the next couple of slides. So let's take a second and make sure that we understand what we're looking at. You have an experiment that has tested the effect of sugar solutions on the height of plants. So most likely these different plants, plant group A through F, they were given a certain amount of liquid, and that liquid was either pure water or had varying amounts of sugar in it. And so then they went ahead and recorded the initial height of the plant so you could see what the growth was. They give you the final height of the plant or of the plants that exist within that group, because it looks like it's an average. So there were probably, 5 or 6 plants in group A, and they ran this experiment, and then 5 or 6 plants in group B. And so they're averaging the data. Regardless, you can look here really quickly. So let's kind of scan it. Group A had straight water, and look, it grew seemingly the most from this data. Final height, it grew 30 centimeters. Plant group B got a 10% sugar solution. It still grew 28 centimeters. Plant group C had a 20% sugar solution. It grew 15 centimeters. Plant group D had a 30% sugar solution. It grew 10 centimeters. Plant group E, 40% sugar solution applied. It died. And plant group F had 50% sugar solution applied, and it died. Okay, so there's our data set. If you were asked to make a claim about this data, I'm going to offer you one example of a claim. We could claim this: increasing the concentration of sugar solutions has a negative impact on plant growth. That could be a claim. We could just talk about the fact that as the sugar solution's going up, the plant height is going down. Another possible claim could be that once you exceed 30% sugar in your solution, plant death occurs. So either of those claims would be appropriate based on this data set. What do we know based on this data? I chose increasing concentrations of sugar are actually negatively impacting plant growth. All right. So let's look at the evidence piece. Evidence is, how do you know what you just said back in the claim? How do you know it? You said you knew it. How do you know it? And so oftentimes, and for us, the best evidence is based on data. Now, there's two kinds of data. There's qualitative data, which typically is based off of an observation. That's okay. It's not the best. We will always push, particularly in experiment where we're collecting numerical data, your evidence should be some numbers that come from your data, okay? Quantitative data. And so again, here's that same experiment. If I were developing evidence for this experiment, remember my claim was that increasing sugar solution negatively impacts plants. How do I know that? Well, a sugar solution of 0% grew the most at 30 centimeters, while a sugar solution of 30% grew the least at 10 centimeters. That's a good evidence statement. Here is not a good evidence statement. If I had said, well, the plants that got more sugar grew the least, that's not wrong, but that's not using your data. So quality evidence statements will use data. All right, let's look at the reasoning component. Reasoning is, why do you know this? Okay, so we had, what do we know? Claim. How do we know it? Evidence. And then why? Why do we know it? Why is it happening? This is our reasoning. Sometimes the reasoning is also called the justification. So if you're asked to make a claim and provide evidence and then justify it, that's where this kicks in as well. So reasoning is usually based on science content, your understanding of a scientific concept, a scientific principle. It's usually based on like something that you've taken notes over that we've learned is true of biology. So again, it's oftentimes called the link between your claim and your evidence. So here's what I know, here's how I know it, and here's why the how connects back to the what. It's linking the two. So again, continuing in our example, for the claim, we had increasing the sugar solution negatively impacts plant growth. Our claim, because we can see the 0% sugar grew the most at 30 centimeters and the 30% sugar grew the least at 10 centimeters. Here's why, our explanation for why that probably is. Well, as sugar solutions increase, the amount of water in that solution actually decreases. So as we dump more sugar into it, there's actually less space for the water. So the more sugary solution we're giving the plant, that actually has less usable water. And so the plant is not taking up enough water and is probably dying. So again, you didn't have to know that. That's kind of I could have dropped some words like osmosis in there. And I know that maybe you learned that. I'm not sure where the cutoff of the end of last year with NTI occurred. But there's our reasoning. There's the science. So claim, sugar solution negatively impacts height. Evidence, I pointed to my 0% sugar solution versus my 30% sugar solution, giving the numerical data for how tall those two groups grew. And then why did that happen? Well, as we increased sugar in the solution, there was actually less available water in that solution. So when we are adding that to the roots of the plants get less water when the sugar solution increases, okay? So that wraps up the end of our notes packet, right? Today was a really short rest of our learning. We're going to practice offering claim evidence reasons in support of data. at our next class together. I want to give you a heads up on something coming up next week before I end this video. So next week, we will begin our isopod lab. Now, you picked up materials from school last Wednesday. We're going to use some of those materials in this isopod lab. But there is one thing that I could not provide to you because they would have died. And also because you can probably find them around your house. So what I need for you to do is I need you to start looking around your house. Look around the foundation of your house. Look around if you have like a wood pile or a bonfire place that you gather wood. If you have woods, pick up a log. Look for these. You would call them probably roly-polies. Chances are you've picked them up before. So you know that they're not going to hurt you. We need about 10 to 15 isopods for our isopod lab next week. So I need for you to start hunting and collecting your isopods, and you need to store them in a container that has a top on it. So maybe get a Tupperware container, but you need to make sure that you poke holes in that top because they do have to breathe. And we need these for next Wednesday. So I'm giving you some time. If you don't feel like you can find them around your house, maybe check with your friends, check with family, maybe other houses, family and friends that live here in the area that could help you on this hunt. I'll survey next week whether or not we were able to find our 10 to 15 isopods, but you need to collect them for next Wednesday. You need to store them in a closed container that has holes poked in the top. And you need to put two things in that container. You need to get a piece of a paper towel and get it wet, damp, and put that in there as well. And you need a piece of scrap food. That's what they're going to feed on. So like a piece of apple, a piece of really, don't give them like meat because that's not going to be a thing that they're going to enjoy. But maybe a piece of produce that you have the core of or the leftovers of or even the rind of. They'll eat on an orange rind. You need to give them a little something in there. If you have a fish tank at home, they love fish flake, fish pellets that you would feed your fish. So you can dump a few of those in there as well. But that just helps give them the kind of environment that they need to survive. So start hunting around for your isopods. Again, next Monday and Tuesday, I'm going to survey to make sure that we have them and try to help you if you can't get some. But we're going to start this lab. We're going to put all of the things that we've learned in this notes packet into use next week by running our first full-length AP Bio lab and then analyzing that data and speaking intelligently about it. Okay, we are done for today, and I will see you all in class later this week. Bye. Maybe.